In every sense, 2020 continues to be a year that many people will not even want to remember. However, in order not to darken the neck, it continues to be an important year in terms of science. We can breathe a little while talking about the missions to Mars, the discovery of the traces of life on Venus. But just before the pandemic started, there was another very important development. In February 2020, scientists working at the Argonne Laboratory of the U.S. Department of Energy and the University of Chicago announced a very important success to the world. Scientists announced that they managed to achieve quantum entanglement at a distance of 83.7 kilometers, the longest distance ever achieved in Chicago at the facility they call the quantum tunnel. So what can we say to us from this now, but the audience of benbarnology is familiar with this subject from the quantum series. We talked about the behavior of matter and energy in this universe, where rules very different from the world we see and experience continue to apply. Therefore, the achievement of this and especially the control of it can make incredible possibilities possible and open very strange doors. Today we're going to talk about one of the most exciting of these possibilities. We will talk about a door that will enable technology, as we know it, to pass all humanity to a new level. Quantum Internet. Success that I mentioned at the beginning may be the first key to this door. It's a key that can deliver a completely new and incredibly fast and powerful version of the Internet we currently use in the next 10 years. It is an area where the underlying bits of the Internet infrastructure we use today, that is, qubits, that will replace 0 and 1s, will rule. As we discussed in detail in the Quantum Computers video, these qubits do not work with a single value, using the crazy possibilities of quantum mechanics. They can be 1, they can be 0, they can be both 1 and 0. In this way, qubits working together can accommodate almost endless possibilities. In this way, when the Internet, which has a certain bandwidth as we know it, will be able to work in a much larger width when there is a quantum Internet, we will be able to connect super powerful quantum computers and similar quantum devices to each other and have the possibilities to perform operations that we cannot even imagine with the possibilities we currently have. David Oshshalom, a professor of spintronics and quantum computing at the University of Chicago, Department of Molecular Engineering, who worked at Argonne, which carried out the quantum entanglement project we mentioned, explains it as follows. The quantum Internet will be a quantum ecosystem platform where computers, networks and sensors exchange information in a completely new system where communication, sensing and computing processes work as a single phenomenon. But it's a question in mind. What will this do for us? More importantly, how will he do this? So what is the quantum Internet? Let's get that out of the way. The quantum Internet will not replace the standard Internet as we know it. You can think of it as a supplement or a branch of the existing Internet. We will continue to share our holiday photos or birthday messages that others have sent us from our stories with the whole world using the normal Internet. We don't need quantum entanglement or superposition to share them after all. One of its most important functions is that it will solve one of the biggest problems of the Internet right now. Security. The quantum Internet has the potential to offer the highest security we can, especially against cybercrime and hacking problems. For example, today, when someone sends a message from Istanbul to Berlin, the signals are kind of distorted as the message travels over a line, due to different interference. When the device of the person to whom the message was transmitted receives this signal, it first solves the problems, strengthens the signal and finally the message can be read. Of course, we cannot perceive this process, it happens in short periods that we cannot understand. But for such a short time, it is enough for hackers to intervene and decode, modify and copy the message. But if this were a quantum message, this wouldn't be a problem. Quantum networks are sent with photons that protect against cyber attacks. Instead of mathematical calculations, we make use of laws specific to quantum physics to analyze messages. It is not possible for these quantum information to be copied, changed, or corrupted. Besides, you know that it is not possible to view this message without changing it. When you look at it, you spoil it. When you try to interfere with the message, we can say that the message destroys itself. In other words, we are talking about an infrastructure that will ensure that any transaction can be these banking transactions, or that state or company secrets are encrypted much more securely. Again, at this point, if we need to touch on the importance of the quantum entanglement experiment that I mentioned at the beginning, this is the most useful and secure system for those who want to exchange information without anyone else's access. To communicate using two particles that are entangled with each other. Because two entangled particles are actually a single phenomenon, no matter how far they are. David Bohm summarized this as follows: actually, the whole universe should be treated as an indivisible, single phenomenon. But if you want, let's put it in a more understandable framework. The phenomenon of quantum teleportation we talked about earlier. Sumit Khatri, a researcher from the University of Louisiana, and his colleagues also published a study on this topic. They theorized the space-based quantum internet. In other words, they believe that a quantum internet network can be formed by sending entangled photons to the world with quantum satellites that will be sent to orbit. Quantum teleportation comes into play here. When we say teleportation, we are not talking about the examples we encounter in science fiction. For now, forget about teleporting yourself to the other side of the world, although there are scientists who believe it is possible in the very distant future. Here's how the quantum teleportation we talked about in the context of the quantum internet works here. For example, two people who want to exchange information or do a process have quantum particles that are entangled with each other. The person who wants to send information can use the entanglement feature of these particles to send the information they want to the other person. Now imagine that we spread these entangled particles all over the world at specific points. Here is the quantum internet for you. But the trouble lies in figuring out how to distribute these particles to the whole world and how to settle them. However, once this problem is solved, an incredible speed will be achieved when a large-scale quantum internet network is created, and clocks around the world can be synchronized instantaneously, even more precisely than today's atomic clocks, for example. In this way, GPS navigation will be able to operate with an accuracy that can be measured with centimeters from anywhere, much more precisely than today. Or scientists will be able to map the gravitational field of the Earth in such detail that even tiny gravitational waves can be detected. Or we can beam photons between telescopes from all over the world to create a giant world-sized telescope. In this way, we will have the chance to observe all the planets around the stars very precisely. Or, more importantly, when a worldwide network of interconnected quantum computers emerges, it will be possible to carry out simulations that we cannot even come close to at this point. In this way, the behavior of molecules and proteins will be better understood and years of drug trials can be reduced to hours. In addition, one of the most exciting possibilities for scientists and therefore science lovers like us is this. We have no idea about the workings of the universe right now, let's be honest. So we have a picture of how quantum mechanics works, but we haven't been able to figure out how it happened and its actual applications. So the picture in front of us is very foggy. But by working together on this internet of quantum computers, all these computers can, yes, make a simulation of the universe, draw a diagram of the behavior of all particles from the first second of the Big Bang to the present, predicting and even controlling the present and the future. But in order for all of these to happen, we first need to solve the technical part of the job. In quantum computers, which we will talk about in separate videos later, we have to deal with problems such as the temperature problem, control of particles. So when you encrypt and store a message with classical storage and encryption technologies, this information stays that way for a long time. But due to the quirks of quantum mechanics, when you encode information into a particle, that particle can begin to decay almost immediately. Or, as you will remember from the observer problem, the particles do not get along well with the outside world and they collapse immediately. They are shy. At this stage, it is imperative that the quantum network you will establish be isolated from the factors of the outside world. But studies on this are also being carried out. Completely purged vacuum tubes can be used, but still, quantum fields leave nowhere blank. In short, even if we are pregnant with possibilities that we cannot even think of, we need some hardware that has probably not been invented yet to use the quantum internet. We could arrive at this stage in 2030, according to Chinese scientists who recently sent a kind of quantum satellite into space. But for that, we will need a flawless engineering beyond the theoretical part of the job. The names, institutions and ultimately countries that will achieve this will simply be the owners of the future. It is our heart that we too should be involved in this meaningful war and be an actor that shapes the future. I don't see any reason why this doesn't happen. I firmly believe that the new generation, which needs change in every sense, is open to innovation, determined and turned away from the most important thing, logic and science, is capable of this. In the next 10 years, 20 years in the age of quantum technology, I want to see the names of these children on chairs, Nobel Prizes, on the list of people who shape the world, and I feel that it will happen. And as always, until we meet again, good thing you are. Yours.